Myself, Dr. Vishwanath, Department of E&C, Rajiv Institute of Technology, Hassan. Today, I'm going to give a demonstration, video demonstrations on how to test the OPAM comparator with zero and non-zero reference, and how to obtain the hysteresis curve using multi-sim. Okay. So, comparator is an electronic circuit. We can call it as a voltage comparator also. So this voltage comparator is a two input circuit that compare the voltage at one input to the voltage at the other input. Usually one input is a reference voltage and other input is a time varying signal, either sine signals or square signal, whatever may be. So if the time varying input is below or above the reference voltage, then the comparator provides a low or high output accordingly. So understood that? So if the time varying input is below, lesser than or greater than the reference voltage, then this comparator provides output voltage, either the low output voltage or high output voltage according to the varying the input signals. So, so here in this comparator, there are mainly we can consider there are two types: inverting and non-inverting comparators. So in this section, we discussing these two types in detailly. So this OPAM consists two inputs. Comparator circuit as shown in the figure, and transfer characteristics is also observed in the screen. So the comparator, we are using the OPAM circuit. So this OPAM consists of two input terminal, and hence an OPAM based comparator compares the two inputs that are applied to its produce the result of comparison of the output. Okay, so let us discuss the one by one. So zero reference. So if the reference voltage VR is zero, the comparator can be used as a zero crossing detector. Zero crossing detector. So observe the waveforms in the screen also from the figure 3. So when reference voltage is zero voltage, then we call it as in a zero crossing detector. If VR voltage is not zero, then that is the reference voltage is not zero, the comparator can be referred to as a level detector. Comparator acts as a level detector. So here in the circuit we are using inverting circuit. Okay, so negative signals we applied the input signal Vi. So 10 volt peak to peak with a 1 kilohertz, that is sine wave signals we apply to the negative terminal, and positive terminal reference voltage. The difference of this voltage of output voltage observed here, and two supply voltage we are using in OPAM because it's OPAM plus 12 voltage and VCC and VE voltage minus 12 voltage. Okay, now. So it's the practical circuits we are using. So in the practical circuit, first we discussed about the non-inverting, circuit diagram of non-inverting zero reference. The circuit diagram and its hysteresis curve for the non-inverting zero reference are were seen in the screen. So in the circuit diagrams, the first we can select the OPAM and the sine signals. The peak voltage is 10 volt peak to peak and 1 kilohertz. Two supply voltage, that is one is positive supply VDD 12 volt and minus 12 volt, negative VE voltage is minus 12 volt, and load resistance R1 is 10 kilo ohm. The outputs are observed in the CRO. And zero reference, how to see the hysteresis curve also I will explain and demonstrate during in the demonstration time. Okay, so the next, the output waveforms, it is a zero crossing. So observe, this is the input signal, sine signal. Here the peak voltage is 5 volt is there. Okay, we can vary 5 volt or 10 volt, not issues. Okay, well, I will show you what happened when the 10 volt I am choosing peak to peak. And but the V saturation and V minus saturations observe. Blue color indicated the output signals and red color indicated the input signal, and the hysteresis curve also you observe in the screen. Okay, let us I will show the demonstrate this zero crossing. So zero crossing reference. Okay, just I will go for the demonstration part. Okay. Yes. So I already constructed the circuit diagram. So for selection purpose, okay, you just go to the component components, okay, uh, op amp, there is analog. So analog, go to the analog in the database, master database, and select op amps. Okay. Select 741. Okay. See the 741. Select the 741 and rest of this sine wave signals. Okay. Sine wave, power supply, sine wave signal. So what is this? AC voltage. We can AC voltage. Select the AC voltage and change the peak voltage 10 volt and frequency is 1 kilohertz. Okay, and similarly VDD 12 volt. Okay, labeling the supply VDD and similar to the minus 12 volt. Okay, so these components how to select? So go to place component. So sources. So VDD, VE, like that you can select it. Okay. So for VDD, select VDD, and VE, select VE components. And okay. So AC power or not okay signal AC voltage. AC voltage. Go to signal voltage source. Select AC voltage. So once connection is established, then we need to simulate this circuit. So just you after completion of the circuit connection, just I will double click on the click on this run button. So double click on this. Observe this. So this is my waveform. Okay. So I need to position. Okay. And white. Okay. So observe this zero crossing. This is red color indicated the input signal, blue color indicated the output signal. So zero crossing. So non-inverting zero crossing output signal is of time. Okay. And how to see the hysteresis curve? Just you please click A bar B. Okay. So this is the zero crossing hysteresis curve. So this way we can now also check verifying the zero crossing inverting. Okay, inverting circuit. So just I will go to the okay. So this is the practical circuit of diagram of inverting zero reference. So here the difference is what is the applying input signal. So non-inverting zero reference where we apply the input signal, pin number 3 of the op amp, that is positive terminal and negative is grounded. Okay, and here in inverting zero reference input, so positive terminal is grounded, apply the input signal to the negative terminal. So negative. So please keep understood that this is the difference where we apply the input. Difference between non-inverting is where we apply positive input source positive terminal. So in inverting, we apply in negative term. Input source apply to negative, and the hysteresis curve is also inverted compared to the previous example. So V saturation and V minus. Okay. So the expected output is C. Between we get the output in negative terminal side. Okay. So similarly, if I go to demonstration part, this is the circuit diagram of the uh, inverting zero crossing. So only I change the voltage source. Positive terminal is grounded, negative terminal is connected to the voltage source. Peak to peak voltage is same. I can keep constant 10 volt or 5 volt, whatever may be, not issues. Okay, plus 12 volt, minus 12 volt. So run the circuit. Say observe the output. Observe the output. So what is the previous one? So in the previous one, both are in line. Output and input are in line, zero crossing. So it is inverting zero crossing. So negative sides, you can get this. So this is the output. How to see the hysteresis curve? Just negative. So compared to the previous, see this is the positive side, okay, and negative. I hope understood that zero reference, positive and negative. Okay. Then next we go for the explanation of what non-zero reference. So I hope already understood that what is zero reference. If VR is zero, the reference voltage is zero. The comparator can be used as a zero crossing detector. So in that we are discussed already inverting and non-inverting zero reference circuit and its hysteresis curve. So next we go for that non-zero reference. So the circuit diagram of non-zero reference, that is, we can apply some voltage, some positive voltage. We applied positive or negative, okay, positive voltage. When reference voltage is greater than zero, observe the voltage transfer characteristics, the output versus input as shown in the figure. So this is the reference voltage shifted the curve. Okay, the characteristics is shifted to the right by reference voltage. The range of input voltage for operation in the linear region, so this is the linear region, is the same, and the saturation voltage are again VDD and VE. Okay, so VDD and VE. So now the inverting configuration, the input signal is applied to the inverting terminal and the reference voltage is at the non-inverting terminals. The voltage transfer characteristics of inverting comparator with a non-zero reference. Okay. Now observe the practical circuit. So this is the practical circuit, multisim circuit I used it in our demonstration. So and their hysteresis curve for the non-zero reference, positive reference. So the changes is apply the input signal to the non-inverting terminal and in negative terminal applying the reference voltage. The reference voltage is plus 12 volt. Okay, so plus 12 volt. So let us verify output waveform. See in line with the output and input. Blue color indicated the output signal and red color input signal, but shifted. The shifted, you can observe this. This is the shifted output value. Okay, and in hysteresis curve also you can observe shifted the output. Okay, so in exact origin is not there. It is shifted to the right side. Okay, so similar to the non-zero reference, negative. So only okay, minus 12 volt instead of plus 12 volt. So for negative reference voltage, minus 12 volt we are using, and even the hysteresis curve is shifted to the negative left hand side. Observe this, the left hand side. Okay, so only the hysteresis curve shifted left side instead of the right side. Okay, so now the difference is in the simple comparator is the instability of its output resulting from the noise when the input is in the neighborhood of the reference voltage. So this Smith trigger provide a method for dealing with this problems. Okay, so here the Smith trigger is there, but in our syllabus we are not executed Smith trigger. just I was explaining also what are the problems occurred in this comparator and how to fix that problems using the Smith triggers. Okay, just I will show the demonstration of the remaining part of non-zero reference. So therefore, just we go to the demonstration environment, that is multisim environment. So just I select the multisim, the non-zero reference positive. The circuit is already I constructed, and so the same component reference voltage, peak to peak voltage is 10 volt. See, peak to peak voltage is AC voltage is 10 volt, frequency is 1 kilohertz, and some component, that is reference voltage is 12 volt. Okay, reference voltage 12 volt, VDD is 12 volt, V is minus 12 volt. Okay, load resistance 10 kilo ohm. Just run the circuit. Okay, observe the red color indicated the input signal, blue color indicated output signal. The output is shifted to the right side because the reference voltage is positive. Okay, and hysteresis curve, just select the A bar B. Then hysteresis curve is also shifted to the right side from the origin. Okay, similarly, we can see the demonstration of the negative voltage. If the reference voltage is negative, what happened? Okay, so same. Just I will stop the run simulation. So now we run the circuit with a negative reference voltage, non-zero. So here I am using a non-inverting circuit. So input signal applied to the non-inverting terminal. Only we change the reference voltage, either positive and negative. Observe the waveforms. Okay. And observe the hysteresis curve shifted to the left hand side. I hope all of you understood and understood the concept of zero referencing, inverting and non-inverting in the comparator. Okay. Thank you for watching the video.